Resistance thermometer. You see, resistance thermometer is based on the principle that resistance changes with the temperature. For most of the metals, we find that change of resistance with temperature is linear in quite significant region. So, we use mostly metals, and that too in particular we prefer platinum because of its high melting point and high value of linear coefficient of resistance with temperature. So, platinum resistance thermometer is mostly preferred. The relation that we follow is R0 1 plus alpha T. Alpha is known as temperature resistance coefficient. R0 the resistance at 0 degree, and this is the resistance at T degree. And with the help of that, if we have two temperatures, T1, T2 with the resistances R1, R2, then alpha could be calculated by this relation. This is R1, T2, R2, T1. Suppose in place of T1 and T2, you prefer 0 and 100 degrees Celsius, then in that case, temperature is given by RT minus R0, R100 minus R0 into 100. So, R0 would be in fact known to you, and you just measure the temperature resistance of that wire at a particular temperature. That temperature could be calculated by using this relation. The second one is thermoelectric thermometer. This is also known as thermocouple thermometer. Thermocouple simply means we use two wires and join them at 2 points. These 2 points would be known as junction. If we create a temperature difference between the two junctions, we notice that an electromotive force is automatically developed between the two junctions. This effect is called Seebeck effect or thermoelectric effect. Also, this is known as Seebeck effect. See, thermocouple, hot junction and cold junction. If the temperature difference between them is T, then EMF that is produced is given by this relation. This is a parabolic relation. If you plot a graph between E and the temperature difference, the graph is this type. But working of this thermometer, that is Seebeck or thermocouple thermometer, is mostly based in the linear region of this relationship. You see, mostly we use antimony bismuth thermocouple. Thermocouple means two metals are used for making two wires, and antimony bismuth we use because the EMF produced is very high. This is of the order of 1.2 millivolt per degree Celsius. But if you further, you see, by taking this couple, the range is going to be minus 200 to 1600 degrees Celsius. But in order to increase or wider the range, we have to replace this antimony and bismuth by tungsten and molybdenum. By using that, you could increase the range up to 3000 degrees Celsius. And the most advantageous thing that goes with this thermocouple thermometer is that it is capable of measuring the temperature that are of rapidly changing nature, like that of insects. For insects, it's a wonderful thermometer.